Okay, so what we have here for our first setup, we're going to look at two dice, a purple dice, a purple die, and a yellow die. And you're going to roll them. And I'm going to ask you, do you have at least 1 6? So, just make sure you understand my little grid here. Could you mark the squares where you have at least 1 6 when you roll the 2 die?
It's here, and then it's here.
Okay, so what did you roll here on this square?
Oh, you rolled a purple 6 and yellow 1.
Okay.
Oh wait, so it would be all of these two.
Okay, so for example, what did you roll in this square?
So you would have purple 3 and yellow 6.
Okay, does that make sense to you? Does that make sense to you?
Yeah.
Okay, so in this game, instead of bridge hands, we have dice, and you roll them. And I ask, do you have at least 1 6? And these are the times where it's true. So if you say yes to this question, what's the probability that you have 2 6s?
It's going to be 1 out of 36.
What do you think?
Well, I think, because if you say yes to this question, that restricts you to only these 11 possible combinations. So, it means it would be 1 out of 11, not 1 out of 36.
Okay. So let's talk about this. If right at the beginning I ask you, do you have 2 6s? What's the probability of that?
It would be, well, this is the only square you can have it, so 1 out of 36.
Okay. Now, what happens when I ask you this question? Do you have at least 1 6? What are the choices?
Well, you can have purple 6, a yellow 6, or both.
Okay. What else could you have when I ask you that question?
Or you could have no 6s at all.
You could have no 6s. So what's going to happen when I ask that question to lots and lots and lots of people?
Well, most of them are going to say no.
Yeah, most are going to say no. And
Some of them are going to say yes.
okay. So if you say yes, what's the probability that you have 2 6s?
Well, so that means you'd have, if you have at least 1, then you'd have, like if you say you had a yellow 6, when you're comparing this, there's only 1 square out of the yellow 6s that has this, so it would be 1 out of 6. And then if you were doing the purple, it would also be 1 out of 6.
Okay. And what's the overall probability then? If you say yes, I have at least 1 6, what's the probability that you have 2?
Or just 1 6.
Okay, why do you say that?
Well, because if you have at least 1 6, the probability of your other die being a 6 is 1 6.
Okay, that's interesting. Each of these squares, where's the marker? Each of these squares is equally likely to be in, right? Like, what's the probability that I end up in the square? I roll a 6, purple 6, and a yellow 1.
It's 136.
136. So I'm equally likely to be in all of these squares. Right?
Yeah.
So in, oversimplifying, if I had 36 people and they each were assigned a different case, how many people would answer yes to do you have at least 1 6?
So it would be 11 out of 36.
And how many of those would have 2 6s?
1.
Okay. So what's the probability of, if you answer yes to do you have at least 1 6, what's the probability of having 2 6s?
And 1 out of 11.
1 out of 11. Okay, can you explain that?
Well, so out of all these 11 possible cases, then only 1 will have at least, they'll have 2 6s.
Yeah, very good. So there's 11 choices for how you might have at least 1 6.
Yeah.
And they're all equally likely to happen. So So you're as equally likely to be here, as here, as here, as here, as here. And so if you do this experiment lots and lots of times, you're right, most of the time people are going to say no. In fact, 25 out of 36 times people are going to say no. And then if they say no, what's the probability they have 2 6s?
0 out of 36.
Yeah, they'll never have 2 if they don't even have 1. But 11 times out of 36, someone's gonna say yes, and only 1 out of those 11 times does anyone have 2. Okay, but now, what if I ask the question, did you get a 6 on the yellow die? Maybe you can put X's through the ones that have.
Well, then it'd be these.
So before we were 1 out of 11. What are we now? What's the probability if I get the yellow die with a 6? Did you roll a 6 on the yellow die? People say yes. What's the probability that you have 2 6s now?
Oh, it would be 1/6.
1/6. Is that more or less than 1 out of 11?
It's gonna be more.
What do you think?
Well, yes, we have a lower initial probability, but a higher second probability.
Okay.
Because this first condition is less likely to be met than our original first condition, but once it's met, you have a higher chance of getting your second condition met, even though it's the same second condition.
Do you see how this at least relates a little bit to the first problem?
Yeah.
All right, now we're going to do a more complicated case with 3 dice.
Alright.
All right?